All right, in today's video, I'd like to show you a new product that I designed to work with existing multi-stage water purification systems. It's called the DI bypass valve. This is very useful, like I said, in multi-stage systems that use a pre-filter, usually a carbon sediment filter, an RO membrane, and then finally a DI to polish off the water. And this would get installed inline between your RO filter's output and just before the DI filter input. So on an eco cart like this here, which fits perfect, it would fit in between this position here. This is where the RO membrane outputs, and this is where the DI inputs, so it would get installed like that. Let me just show you what that would look like installed. So here it is, already installed here. So like I said, we have the RO membrane here. It outputs whatever it can get the water TDS level down to. And before going to the DI, we would put the DI bypass. So there are three main benefits of using a DI bypass valve in your system. But before we go over those benefits, let's just kind of do a recap of the relationship between the RO and the DI. Now, after your source water goes through the pre-filter, it goes through the RO membrane, and if an RO membrane is brand new, the TDS reduction is usually about 95% before it outputs and goes to the DI. In other words, if you have a relatively low TDS incoming water of 100, 95% reduction will bring it down to 5. So you only have 5 ppm entering in your DI chamber. Perfectly fine to run the system like that. However, there is a problem that may occur where you have, maybe you're in a particular location where you have very high TDS source water, 400, 500. I've even seen as high as 900. And what happens is the RO is not going to bring it down by that 95% just like that. It's going to take a little bit of time. The higher the TDS level is going in, as well as how how aged the RO membrane is, it's less efficient. It might take a minute. It might take several minutes. And of course, if you have an RO system that has the output of the RO pure side going directly to the DI, you've got a very high TDS water coming out and going into your DI before this stabilizes, which means your DI is going to wear out prematurely. So benefit number one is that what you can do when you start up in the morning in your first job, once you turn the source water on, turn the DI bypass valve to the open position, and all this higher TDS water that this is producing is going to come out through the bypass valve. And you can take measurements, and you can see it's going to be very high to start off with before it goes lower, 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 and then finally stabilizes. Once the RO is producing a steady low amount of TDS, then you can turn off the valve and redirect it back to the DI. So let's take the system outside and do a test, and I'll show you what I'm talking about. At my location, my source water is 160 ppm on the TDS meter. With the DI bypass valve open, we'll take a measurement of what the RO is producing right from the get-go. So it's taking 160 down to 109 when you initially start up. We'll take another reading. Now we're at 79. A few more seconds later, we'll take another reading. We're at 41. Take another reading a few seconds later. 27. 21. It's getting down there. Next, we're at 17. So it's reducing at a slower rate at this point. Now we're at 14. A few more seconds later, we're still at 14, so the RO is now stabilizing at what it will normally produce. And finally, it's at 13. So we're pretty much stabilized now. At this point, we can turn off the DI bypass. First thing you'll notice is now the DI housing is starting to fill up with water. Once it gets up to a certain amount, it will start flowing out through the DI filter. So let's have a look at that. There it is. And we'll take a measurement of the DI, what's coming out of this system. It's exactly where we want it to be, at 0 parts per million. So now on to benefit number two on why you might want to use a DI bypass valve on your multi-stage system. Since we have a way now of monitoring what's coming out of the RO before the DI, it's a great way to monitor your RO membrane's performance over time. Season 1, Season 2, or Season 3 of using it, you can see how it goes from new state of about 95% mineral reduction to anywhere down to like 80% by the time the industry standard says you should probably be changing out that RO. Because if you don't, it gets lower than 80%. The DI has to work so much harder, so you'll be spending a lot more on replacement resin. So I did a video a while back on how to do a calculation on taking your incoming TDS measurement versus your output of the RO. For those of you who haven't seen it, I'm just going to show you on a calculator how to do that kind of a calculation. So for our test calculation, we'll assume 160 parts per million going into the system, and if the RO on its own produces an output of 8 parts per million, that gives us a difference of 152. If we divide 152 by our source water of 160, it gives us this number. If we want to move the decimal point, we times it by 100, so that's a 95% reduction. Now in our little example where we took the machine outside, I had 160 going in, and the RO, when it finally stabilized, was producing 13 parts per million, of a difference of 147. 147 divided by 160 gives us this number, times 100 shows us that we're just under 92% reduction. So that RO is still in pretty good shape. So for our final example, if we had 160 parts per million going in, and the RO was just producing, let's say, 45, that gives us a difference of 115. 115 divided by 160 gives us this number. Move the decimal point over, that's less than 72% reduction. Long overdue for replacement on that RO. And now on to the third benefit of using a DI bypass valve. Some of you may have already kind of figured it out. Now, I told you that a brand new RO should produce 95% reduction in the incoming TDS, which means if your incoming TDS is low enough, let's say 100 or even 150, and this is reducing it by 95%, your output from just the RO alone is going to get below 10 parts per million. And what have we said in the industry standard for cleaning with spot-free results? Anything up to 10 parts per million, you should be good. So if you have that kind of a situation, you can actually tap right into there and hook up your water-fed pole to here and not even use the DI. That's a very good situation too. If preferably you might want to have 0 TDS, but let's say your DI is spent and you haven't had a chance to order from places like me to order more resin. If you take a testing of what's just coming out of the RO and it's low enough, you might have to, you can totally bypass the DI, hook up your water-fed pole to here, start cleaning. Like I say, as long as it's 10 or under on parts per million, you're all set to go. So here's the close-up of the DI bypass valve. As you can see, it's high-quality components. It's using brass and nickel-plated brass. It's got a pretty good heft to it. It's not a cheap product. It's not going to break easily. And although I did design this to be a perfect fit into the EcoCart, the output of the RO into the DI, it could pretty much work with any multi-stage system, provided that the hose that goes from the output of the RO to the DI is using a 1/2-inch tubing. These are 1/2-inch fittings here. So you could just tap in. You want to tap in just right before the DI of your system. Well, I hope you found today's video helpful. If you want to check out the DI bypass valve, go visit us at thewindowcleaningstore.com. Thanks for watching.